Hey all, welcome to Docker Analogy series where we are learning and mastering Docker each day. In the last video, we talked briefly about our inability to store the to-do list beyond the container lifecycle. But in today's video, we are going to learn an interesting topic on how to persist the data beyond a container lifecycle. Now let's look at the problem first, okay, and then we'll try to look for the solution. Okay, so I'm going to my terminal right now. Okay, so I have, if I do docker ps, I have my to do app container running, right? So I have named it as to do app a. Let me open yeah, so localhost 3000, you can see I have my to do app running. So let me add some atoms. Repair or service my car, buy a toy for Ira's birthday, go out shopping with wife. Okay, so these are my to do items which are currently showing up on the screen. Now what is the problem here, right? What happens if I shut down the container? So docker stop to do app a. Okay, once I stop the container, I wouldn't see anything running, and this will also stop. Now what if I remove a container? Okay, docker rm to do app a. Okay, so I removed the container. Now let me restart this container again. Okay, docker run, yeah, so I'm running a container. Okay, so I'm running a container in a dash mode, having my ports mapped with the host machine, right? And the name is to do app a. Okay, and this is the image. So I'm running container. If I'm going back to my ports now, okay, you can see the to do items that we had, those are vanished now. Those are not here. Okay, now let's try to understand what is happening here. So when we created a container, okay, that container had its own file system. Okay, and as soon as, and it was isolated, and as soon as we stopped and removed that container, or in fact when we removed that container, all the file system associated with that container got wiped out. Now this is a dangerous situation to be in. The reason being, in a actual production environment, right, if you use orchestrator, now I am throwing this jargons here, orchestrator, and if you are new, it might confuse you. So let me in a brief explain what is orchestrator. So consider orchestrator as a authority or a person, or in terms of computer world, let's consider authority as a process which watches over the containers which are being executed. Or you assign him a task, you assign that process a task that I want 2 containers of my app to be running, I want 1 container of my database to be running, right? This is the task you assign, and then that orchestrator make sure that the 2 containers of app are maintained all the time, and 1 db container is maintained all the time. If one of the containers goes down due to some issue in the code or due to some memory crunch, the job of that orchestrator is to bring up the container which has gone down, and its job is to maintain the state which it had been assigned to run the containers with. So 2 app containers and 1 db container, it will try its best to maintain that state. Now imagine that you are running a production environment, and all of a sudden your containers goes down, and a lot of things can go down, a lot of bad things can happen in the production environment, right? You run out of RAM, you run out of hard disk, right? And your containers get removed because of that, and all of a sudden you lose all the data, right? Which is not the correct thing to do. So that is the reason we need Docker volumes. And so Docker volume is a way to manage and persist the data in Docker containers. Volumes provides a mechanism for sharing the data between a container and the host machine, or between the multiple containers as well, and we are going to look at that example as well. They are used to store data and manage data that needs to persist beyond the lifespan of a single container, such as configuration files, database logs, and other application data. If you remember our life cycle, right, Docker life cycle, right, you can start a container, it comes into a running state, then it can go to a pause state, come back to running state, it can be stopped, it can be then deleted, right? So we want data to be persist beyond this life cycle. That's why we want to study Docker volume, and there are other advantages also. Now before we go into the Docker volume, I want to quickly show you how does it, like I want to show you a file system, right, of the Docker. So right now I have my container running Docker app A, like to do app A. Let's go into the let's explore the file system, right? And there are two ways to do it. If you remember, I had shown you how to do that in a Docker desktop way. So if this is the container running, I can view the details, right, and then I can actually go into the file system, right? Here I can go the file system and it will show you everything, okay? But as I had told you, Docker desktop is not available in the production environment because your servers run in a Linux system mostly. So you need to be good at Docker CLI, okay? So that's what we are going to do, right? So there is this command called docker exec, right? Let's read about this, right? Docker exec executes a command in a running container, okay? This is what we want, right? We want to be able to access our container in a shell environment where we can debug, we can get some information regarding the current file system, okay? And there are two important options we get here, right? One is interactive, okay, which is -i, and another is -t, and we will look, how to what is their meaning. Now when I say -i or interactive, so this option makes containers interactive, allowing you to interact with running containers process. When you use the -i option, so Docker keeps your standard input open, which means you can provide input to the containers process just like you would with a regular command line session. And this is helpful for running containers that require user input or running a shell within the containers for debugging or maintenance. And about -t or -tty, this options allocates a sudo tty, or a tty is pronounced as teled typewriter. It is basically terminal for your container, and it emulates a terminal interface, which is particularly useful when running a shell session within the container. And this option ensures that you can use terminal features like colors, cursor movement, and other terminal specific behavior. And both these options are generally used together, right? So now let's get into the Docker file system, right? So docker exec, I want to execute a command interactively, and I want a terminal as well, right? On what container I want for that to do app A, okay? And I want to run a shell script here, so okay, so I'm going to do sh, okay? Now you can see as soon as I run that command, I get this interactive shell and a terminal like feature where I can actually now run it like any other shell, right? So if I do ls, we know that home node app was our current working directory or working directory that we had set up, and so when we do sh, that's where we are brought back in. And then you can choose to look at other things around here, okay? When we do ls, you can see this is our code base, right? What we saw from Docker desktop, similar things can be seen here. So you can see lssrc, you can choose to read code through cat command, right? You will see everything here. Now let me create a file here. I think we saw an example of to do app. Let's do one quick example. So I'll do vi test.txt, text.txt. We are learning about Docker volumes. This is a text file to learn, to investigate on the same topic. Let's save this one. Okay, so you can, if I do ls, you can see test.txt is here. Okay, now if I exit, okay, my container is still running, so file does exist. So now if I do docker exec -it, if I do ls, my file still exists. Okay, let's exit. Okay, and then what I'm going to do is I'm going to stop a container, docker stop to do app a. So docker ps shouldn't see show anything, right? So we are good there. Let's run that container, docker start, because it's just a stopped container, so we can use docker start or docker restart as so. So now the container has started. Now let's get into the container one more time. Yeah, and then you can see the text.txt does exist. Okay, so the important thing to remember is the data is persisted as long as docker container is not removed. Okay, if it stopped, it restarted, you will continue to have that data, that file system still exists. Okay, but let me remove now docker rm to do app a. Let me stop first, docker stop to do app a, and then docker rm to do app a. So container got removed. Let's run the container one more time. Run. So container is running right now. Let's get into the container now. Docker exec. If I do ls now, you can see the text.txt is gone, right? So why did it happen? The reason was we were not able to persist the data beyond the container life cycle. And as soon as docker container was removed, everything with it got wiped out. And in a production environment, containers getting removed is quite often. If you use, as I earlier said, if you use any orchestrator, the orchestrator will remove your containers, bring back the new containers. So you want your data to be persisted, right? That's why we want to study what is Docker volume. So let's learn about Docker volume in detail now. What is Docker volume? Okay, and then what you can do with it. So I have this diagram, you can see on the screen. So when you create a Docker volume, right, what you can do is you can map that Docker volume on your host machine. Okay, so whatever data then that gets created on a specific volume inside a container, that gets replicated or gets written on the host machine volume. So you can see this is my host machine, right, and this is the container running inside that. And if you create a new container and if you use a specific, and if you mount a specific directory on the host, then whatever data that gets written here gets also replicated on your volume. Okay, and no matter if this container goes down, right, new container comes up, if it uses the same container, same image and the same path, then it is going to see the existing data created by this container. This is what we want basically. Let's look at the Docker CLI and see what does Docker volume say. Okay, so you have this docker volume -- help. Let's read about this. Now these are multiple commands we get. Okay, what does it says? So docker volume create, and then if you give it a name, so docker volume create -- help, you can give it a name, right, options, and then actual volume name. It will help you create a volume. Let's go ahead and create a volume. So I'm saying docker volume create. The volume name is to do app. Now if I want to list all the volumes, I can do docker volume, let me do help, and then ls list all volumes. Okay, so docker volume ls, it will tell me, oh, there is this new volume which is available. Now do we have existing container running. Okay, what you want to do is I want to stop this now container docker volume to do app a. Let me remove this container as well, docker rm to do app a. I've removed this container now. Okay, now what I want to do is when I create a new container, I want to associate the new container and I want to map the volume while I'm running container. Okay, now the volume that we have created, we want to mount that volume and or attach that volume to the file system, right? Let's run. How can we do that? Now if I do docker run minus help, okay, minus help, so you can see here there's this option called mount, right? What it does, attach a file system mount to the container. Okay, so we can attach a file system, local host file system, to the container file system. Okay, let's try to explore on this further. Okay, now if I want to run a container, so we already have a docker volume, we know that we have a docker volume ls, right? Let's look at the code also, right? What do we want to mount, right? So now if I am in the code, right, if you go to, so we are using SQLite here, if you do not know that already. For example, for persisting the data, there are two options in this application. I will you can find the application code from the GitHub. You will find the GitHub link of this code on the description. Go and check it out, right? So now right now what we are using SQLite currently to actually store the data. SQLite is a like fairly simple database, and you wouldn't probably use that for a backend application, but for simple demos we can do that, right? And if you look at here, when I'm running this application where I'm persisting this data, so this is under persistent and then SQLite.js, right? SQLite.js. Either it is checking if there's an environment variable which is passed. I think we haven't talked about environment variables, how to pass environment variables through containers. We'll talk about this maybe in the next video. Or there is this default path where it is storing the data. So let me see if I have a Docker container running. Now let me quickly run this so that I can show you. Okay, so my Docker container is running. Let me do execute now. So if I go here, if I do go to etc to do, right, you can see etc to do's, and then under that we have to do's.db, right? So this is the file where data is getting stored, and this is a like basic schema or the way the SQLite stores the data. What we want to do is we want to mount this location so that the next time when the new container of to-do app starts, it will try to pick up the data from the same location. Okay, and it will find that data not on the container, but because the actual path will be mounted from the host file system, then it will be able to pick up or memorize existing to-do items, and then it can pick up from that. So it will pick up from the place where the earlier container had left, right? This is what we want to do, and let's see how can we do this. Now let me remove the existing container, to-do app a. So docker stop the running container, docker rm the running container. Okay, now what I'm going to do is I'm going to run a container, attach a volume to that. Okay, let's see how can we do this. So I'm saying docker run -d for detached, -p, I want to do port mapping. I want to map 3000 port with 3000 container ports, host port 3000, container port 3000, and then minus mount or -m, and then I can write type. Type is volume. Source is what is the volume name that we had created. If you remember, we had created to do app, let's see, docker volume, docker volume ls, right, to do app. So we are correct there. So this is, let's copy paste, let's use this one. To do app is the name, and what is the target? Okay, the target is the container file system. What do I want to mount? etc slash to do's. This is the location, or this is the directory where my to do db is getting stored. Now what happens, like when you store this data, it gets replicated on the host machine also, right? So this is all good, and then minus name, let's give it a name, to do app a, and then what is the image we want to run? To do app colon 0.0.2. let's run it. It says did not find it locally. Okay, I know, I think I got it. So my name is not to do app, but I need to give my namespace also, right? Yeah, so container has started. So you can see docker ps container is up and running. Let's try to access this. Okay, now we are able to access this now, which is good. So let me store a few items here. Clean home for Diwali, add an atom. Buy diyas, not buy diyas for Diwali, again lot of atoms for Diwali. What else? Oh, buy firecrackers. How can you forget? Buy firecrackers. Okay, now these are the items which I stored. Okay, let's mark one of them as, let's say, done atom. For example, I bought diyas for Diwali, so this is done. Okay, now let me stop this container. Docker stop to do app a. The container is stopped. I cannot access the page, which is fine. I want to remove this container now. Docker rm to do app a. The container is removed. Okay, still cannot access, which is fine. Now I want to run this container. I want to check if I run a new container, can I get my data back, right? Let's try that out. Let me execute the same command, docker run, running in detached mode with a port, high port, host port, container port, and with a mount information that this is, I'm mounting a volume. The source volume name is to do app. The target in the container is etc slash to do's, name of my container to do app, and the image that I want to run. Let's run this. So your container is up, docker ps. Let's refresh this. Okay, ta-da! So we got everything intact. So we had 3 items before we removed that container. 3 items are intact. Clean home for Diwali, buy diyas, buy firecrackers, all items are intact. We had marked buy diyas for Diwali item as done. That item is intact as well. I think now you remember what does the docker volume helps you with, right? You can persist that data and you can bring beyond the container life cycle. So that's the importance of volumes. I hope that made a sense, and the whole demo actually helped you understand the docker volume. Before I stop this video, I want to quickly talk about some of the advantages about docker volume. The first is data persistent, right? Volume allows data to survive the life cycle of containers. When a container is removed, the data is stored in its associated volume, persist, and then can be attached to another container, as we saw. The next is shared data. Now volumes can be shared among multiple containers, enabling data sharing and collaboration between the different parts of an application or between the different services. So you can have multiple services running, right? And they can still point to the same data on the host machine or the volume that you create. Next is the performance, and volumes are more efficient actually for storing and managing the data. And they are typically faster and more suitable for the production use case, as we just saw. The next is isolation. data stored in volumes is isolated from the containers file system, right? And this separation helps prevent accidental data loss when containers are removed and replaced, and we saw that with an example. The next is easier for backup and restore, right? Volume makes it easier to backup and restore the data, as you can back up the volume independently of the containers. That's the importance. So I think with that I want to stop this video. There are a few more things I wanted to cover, but maybe let's try that in the next video. Okay, thank you everyone. Bye.